Hey guys, this is the video for week 8. A couple of things I want to let you know before um, you get going on this. It's really important that you watch the entire video, okay? So I've kind of edited this, so there's this introduction really brief. Then there's a couple minutes explanation of what you have to do for the week. And then at the end, there's some lessons. So like I wrote out how to calculate protons, neutrons, and electrons, how to use 8-man, how to draw a Bohr model. Super important that you watch the entire video. And again, this part won't be very long. The next part of this video is me explaining what you have to do for the week, what the expectations are, what's going to be graded. And then the last part is me showing you how to do everything. Drawing a picture of an atom, locating where protons, neutrons, and electrons are, how to use 8-man to calculate the number of neutrons in an atom, how to fill out the chart, how to draw a Bohr model. It's all right there. So you have to watch the entire video, okay? So make sure you do that, all right? Because everything is in the video. Now, of course, if you have any questions, you can always email me or private comment me and I'll get back to you. But just make sure you watch the entire video, because how to do all of this stuff is there. Don't just go in and fill stuff out not knowing what's going on and you get a bad grade on it, okay? It's all right there for you, all right? So again, this is week 8. Make sure you turned in week 7. If you haven't finished week 5 or 6, make sure you do that as well. Because starting with week 5 all the way forward, that's what's being graded for the 6 weeks. Okay, so make sure you watch the whole video. Don't skip out on it. Everything you need to know is in the video. All right, guys. Miss y'all. Hope everything is safe. Hope everyone is safe, and keep up your hard work. Thanks, guys.
Okay, guys, so this is just a brief overview of the tasks or the assignments that you have to do that will be graded. Okay, so we're going back into what we did in the fall with chemistry. So we're going to be reviewing that information. Okay, so this is the week at a glance on Monday, and you can break this up how you want. You can do it all at once as usual if you want, or if you just want to do a little bit each day, you can do that as well. So this is just kind of a template of how you can attack the week. Okay. So Monday is parts of an atom, and there's no ed puzzle there, so we can get rid of that. You don't need to worry about the ed puzzle. Um, so you can scratch that off right there. You don't need to do that. But there is a matching activity, calculating protons, electrons, and neutrons. Periodic table match that really has to do with the metals, nonmetals, and metalloids. And then you have to draw 2 Bohr models, and I'll kind of show you how to do that. And then Friday is not the summary. Friday is a form. Okay, so there's a 10-question form on the last slide that you just click on the link and answer those 10 questions. Okay. All right, so let me go through each individual slide so that you know what has to be done. So here's a joke, of course. Why should you never trust atoms? Because they make up everything. And that, while it may not be very funny, it is true. All atoms, or everything in the world, universe, Earth, wherever, are made of atoms. And that periodic table that we talked about with the 118 elements are the ingredient list for everything, okay, whether it be living or non-living. Okay, all those 118 atoms, elements make up everything. Okay. Okay. So this is Mondays, and what you're going to be doing here is you're just going to be clicking on these boxes and moving them to the appropriate text box. Okay. So for example, I'm not saying this is right. So you would just click on nucleus here, and then you would just drag it and put it here if you think it belongs there, or here if you think it belongs there. And you're just dragging it and putting it into place. Okay, and so you're going to do that for each one of these boxes. Is you're just clicking it and then moving it and placing it where it belongs on the drawing. Okay, so that's Mondays. Tuesday, there's some 8-man practice. So this is a slide just to kind of refresh your memory. And at the end of this video, remember, I've given you specific instructions. I've done all of these examples for you. So it's really important that you watch this entire video. Okay. So here, what you're going to be doing is you're going to be filling in this chart. And we've done this before this year at the beginning of the year. So you're going to look up the periodic table, and you can do that on your Chromebook. You're going to find the atomic symbol N, and then you're going to fill in this information about them. So what the atomic number is, how many protons, neutrons, electrons there are. Okay. Excuse me. So for example, nitrogen is atomic number 7. So based on that information, then you would fill in the rest of this information. Okay, so I'll just do the first one for you. So protons, remember the atomic number tells us protons, and it also tells us electrons. So if the atomic number is 7, that means there are 7 protons and 7 electrons. The atomic mass, which is that number at the bottom, the bigger number, is, you remember you got to round that to the nearest whole number. So that's 14. And then in order to find neutrons, it's mass minus atomic number equals neutrons. So 14 minus 7 equals 7. Okay. All right. So there's a link. If you click on the periodic table, it'll take you to a link to just review some information about the periodic table. Here, what you're going to be doing is you're going to click on this box here, okay, and then you're going to move it up and down so that it matches which periodic table over here on the left that, okay, so that's just the easiest way to do that. Of course, you could also just draw lines, you know, if you think this periodic table matches this one, or if you think it matches this one, however you want to identify the text and what it matches to with this. So drawing lines may be difficult for you. So if you just want to click and drag these boxes and sort them in the proper order. Okay, so that's this one and next slide are the same. So you're just taking these text boxes and then moving them up or down so that they match with the periodic table on the left. Okay. Okay. And then the last part for the week on Thursday actually is the Bohr models. So this is a link. If you click on this link right here, it'll give you some information about Bohr models. But I also did this for you in the video later on. Okay, so you could either click on the link and do it, or you can watch this entire video and it'll explain it to you. Okay. So what you have to do is this. So you have 2 elements here. You've got lithium here and helium over here. So what you're going to do is you're going to take these protons are in blue. Okay, protons are in blue, electrons are in yellow, and neutrons are in green. And you're going to click on one of these protons and put them here. So like, for example, if you think lithium has 3, basically what you would do is you would click on this dot and then you would drag it into here, and then you would click on this dot and drag it into here, and then you click on this dot maybe and drag it into here, and then the same thing with neutrons and electrons. So you're basically just grabbing these dots and putting them into the nucleus. This is the nucleus right here, and then this is the first energy level. How many electrons would go in the first energy level, and then how many electrons would go into the second energy level. Okay, so you're just clicking and choosing these pieces and putting them there. You don't have to use them all. I think I put enough in there so there's more than what you need. So it's okay if you leave some of these particles inside the boxes. Okay. And then the last thing to do for the week is the link to the assessment. So once you're done with all this, you get right here, just click on this link right there. It'll take you to a Google form where there are 10 questions for you to complete. All right. So remember, get in touch with me and stay tuned. Don't stop the video right now. The instructional piece of how to do all those things is coming up. All right. All right. Have a good week, guys.
Okay, so this part is talking about the parts of an atom. So you'll have a drawing similar to this on your assignment. So I just wanted to review with you the parts. Remember that the center of the atom is called the nucleus. So this whole section right there is going to be called the nucleus. Okay. And then inside the nucleus, we have two different subatomic particles. We've got protons and we have neutrons here. The reason I can tell that these are the protons is because they have a positive charge. Okay. So this guy right here is a proton, and this guy right here is a neutron. Okay. So when we add up the entirety of all the particles that are in the nucleus, protons plus neutrons, then that gives us something called the atomic mass. Okay. So in order to find the atomic mass of an atom, all we have to do is add the protons plus the neutrons. Okay. So the entire mass of the atom is located right here inside the nucleus. Now, we do have other particles that are in the nucleus. We call these particles electrons. Okay. And those are negatively charged. Okay, so protons are positive, electrons are negative. Now, notice that there are 3 total electrons in this atom, but notice that only 2 of them go into the first level. So these are energy levels and they can hold certain amounts of electrons. So in this case, there's 3 total electrons. So the first 2 would go into the first energy level, and then the last one would go into the next level. And if you recall, this level can hold a number of 2 electrons, and then each level after that can hold 8, and then a third level could also hold 8. Okay, so this whole area where the electrons exist, okay, is called the electron cloud. Okay. And then inside the cloud, of course, we have the levels. And then this electron also has a special description because it is the electron that's in the outermost level. Okay. This electron is also called a valence electron. Okay. So again, to review, the nucleus is the center portion that contains both the protons and the neutrons. Okay. The outer portion outside the nucleus is called the electron cloud that contains the electrons. Any electrons that are in the last level are called valence electrons. It doesn't have to just be 1. It could be up to 8 valence electrons. And then, of course, the non-charged particle that's inside the nucleus is called the neutron. Okay, the next part we're going to talk about is identifying how many protons, neutrons, and electrons are in an atom based on the information that the periodic table gives us. So here we have an example of an element box. This is the element box, of course, for carbon. And in most periodic tables, you're going to find at least these 4 very important pieces of information. The number here at the top is the atomic number. Okay, so that's how elements are organized in the periodic table, is by their atomic number, and that number is significant not only in the order that it is on the periodic table, but it also lets us know how many protons are in an atom. And we'll talk a little bit more about that in a second. Okay, this number right here is called the atomic mass. Okay, and that is the mass is the total number of protons and neutrons that are in an atom's nucleus. Okay, and so in order to work with that, we're going to have to round that into something called a mass number. But those two words can be used interchangeably. So, so right now we've identified that there are 6 protons in carbon. This number we would round to 12. And so that tells us that there are 12 protons and neutrons combined in the nucleus. So if we know that there are 6 protons in the nucleus, and we know that the total number of particles in the nucleus is 12, if 6 of these are protons and neutrons is the other thing, then it's pretty easy to understand that the other 6 particles have to be neutrons. Okay, and we'll talk about 8-man here in just a second. The next thing is the element symbol. C for carbon. Of course, that's pretty simple, like O for oxygen or H for hydrogen. But remember that not all of the elements on the periodic table are single letters. Sometimes there's 2 letters. For example, helium. So we have hydrogen and helium that both start with the letter H. So we use H for hydrogen, but for helium, we're going to use He, all right? And then to even make it more confusing, sometimes the element is given 2-letter symbols that have nothing to do with the name that we call it. So some examples are silver, Ag, gold, Au, lead is Pb. We talked in class earlier this year about that being the Latin name for those elements. So silver in Latin is called argentum. That's why it's Ag. Gold in Latin is aurum, A-U-R-U-M, and so that's why gold is Au. And then lead in Latin is plumbum, and that's why we use the Pb for lead. Okay, and that's where the word plumber comes from, because they used to work with lead pipes. And then the last thing in the element box, of course, is the element name. Okay, so talking about 8-man, so this is kind of a little trick in order to help us figure out how many protons, neutrons, and electrons are in an atom, and you're going to need this for the next activity that's in your assignment. So here we're just looking at the ape. A is the atomic number, P is protons, and E is electrons. So for automatically, when you see a box like this for carbon and the atomic number is 6, that automatically tells you that there are 6 protons and there are 6 electrons inside the atom. So the only other particle that you need to be able to know is the neutrons, and that's where the man comes from. Okay, so M stands for the mass, so we're going to take this mass, 12.011, and we're going to round that to the nearest whole number. So in this case, the mass of carbon is 12. The atomic number of carbon is 6, and that's going to give us how many neutrons are in carbon. So for carbon, there are 6 protons, there are 6 electrons, and there are 6 neutrons. Now, not all atoms come out that way. As we get further down the periodic table, the number of neutrons begins to increase upwards to a point where something like in uranium, number 92, it'll have 92 protons, but it could have somewhere in the vicinity of 150 neutrons. So it's not always equal, right? So on the next part of the assignment, you're going to have to be able to use this formula or this trick here to determine the numbers of protons, electrons, and neutrons that are in an atom. So in order to fill this chart out, which is in your assignment, okay, I did a video a minute ago and did this, but then something happened, and so I have to redo it. So I apologize for that. So in order to find what fill in the blanks is, you have to identify, of course, what the element is, all right? So here we look for atomic number, and that's number 4. So we would go to the periodic table, which you have a link to in your assignment, and you'll look at the atomic number of 4 belongs to the element beryllium. Okay, so you would type in Be in the symbol column. If the atomic number is 4, remember APE for ape. If the atomic number is 4, then that means there are 4 protons and 4 electrons. And then if you look at the element box for beryllium, you'll find that the atomic mass of beryllium is 9. And so remember, atomic mass is protons plus neutrons. So if we know that there are 4 protons and we know that there are 9 particles in the nucleus, then that means the other particles have to be neutrons. Okay, so these two numbers here, 4 plus 5, should always add up to the answer here. Okay, all right, so you're going to practice doing that on your assignment that looks like this inside the Google slideshow. Okay, so the last thing you're going to have to do on your assignment is to make 2 Bohr models. Okay, so in order to make a Bohr model, we have to first determine how many protons, neutrons, and electrons are in an atom. And then once we do that, then we can place everything where it needs to be. So for this example here, we're going to talk about carbon. So carbon is number 6 on the periodic table, so that means there's 6 protons. That means there's also 6 electrons. And then the mass of carbon is 12, so 12 minus 6 gives us 6 neutrons. So once we identify how many protons, neutrons, and electrons there are, then we can place the protons and neutrons inside the nucleus, and that's what the box represents. So we're going to put 6 protons in here and 6 neutrons in here. And then we have to place the electrons around the nucleus. So because there are 6 electrons, that means I'm going to have 6 electrons placed around the nucleus. So we draw our first circle. And we should know by now that in that first circle, only 2 electrons can go in the first circle. But we need to have a total of 6. So once I've filled the first circle, then I have to go and draw a second circle. Okay. And so we need a total of 6. I've got 2 here, so that means I would put 4 in the outermost energy level, just like that. Okay, so we'll do it one more time over here with oxygen. So I get on the periodic table and I find that oxygen is atomic number 8. So that means that there are 8 protons and 8 electrons. And then the mass of oxygen is 16. So 16 minus 8 gives us 8 neutrons. So then I put inside the box 8 protons, 8 neutrons. I draw my first energy level. 2 electrons can go in the first energy level. And if I've got 2 down, then I only need 6 more from the 8 electrons. So I draw my second circle. And then I place the other 6 electrons in the second energy level. And we make sure we want to space them out. We don't want to just put them all together like that. Okay, so that's how we draw Bohr models. The 2 that you have on your assignment, I believe, are helium and lithium, so they're smaller than these 2. And you'll have blue colored dots for protons, yellow colored dots for electrons, and green colored dots for neutrons, and you'll just have to drag them from the center over to the model that's already given to you. Okay, so again, to start, before you do anything, you have to always determine protons, neutrons, and electrons. And pretty much everything that we've done up to this point is understanding how to calculate those 3 subatomic particles.